We're going to start on number. Number 4. There's number 4. Write that down. Again, don't do work on the pink, of course. Do it in your notebook. Good notation. Hey, I don't know how to convince you about having good notation, other than to tell you repeatedly that students who did not score well on the first test nor on the first retake, when I look at their work, it's usually the notation is horrible. It's just like a pile of junk. And somehow they're thinking that this pile of stuff will produce a valid answer. Use the equal sign correctly, appropriately, consistently. You will do better. Guaranteed. Okay, you just will. Questions? So write this down. The first step is the same as it has always been. We take the derivative of both sides. So that's nothing new. What is new is you do not have a rule that will fit this, at least a rule that we've used. For example, if you tried to use the E rule, it would work for this portion, but it wouldn't work for this portion. So E rule would work here, but not here, so you can't use the E rule. If you try to use the addition rule would work for this part, but not this part, so you can't use the addition rule. The rule you're going to use is the product rule, because this is the product of two functions. Here's a function, here's a function. The product rule looks like this. It's on your sheet. It says if you're finding the derivative of two things multiplied together, you can split them in this fashion to create two smaller problems. So instead of finding the derivative of one large function, we're going to work on two smaller problems, just kind of like we've been doing. So, questions so far? Okay. So that's what I did. This is just the version of the product rule that's on your sheet. So I took the second function, 2 minus x squared, multiplied by derivative of the first, plus the first function multiplied by derivative of the second. So I'll give you a chance to catch up in your note. Awesome. Okay, once you've used the product rule, there's really nothing new to teach you. Like there's no new calculus. Now it's just exactly the same as what you've been practicing now for 3 days. So we can do a little bit more in our head now than we once could, so we can eliminate a little bit of writing. So right here, raise your hand if you know what this is equivalent to. Just do it in your head. So show me your hands. Who knows what this is going to be equivalent to? Just waiting. So this part here, the derivative of e to the x. What am I going to write on the next line? We'll pay everybody for this. So Elijah, what is it?
E to the x.
How many knew it? 0.2 for Elijah. Over here, you're going to use the addition rule first. Then you're going to use the fact that the derivative of a constant is 0. And you'll use the power rule here. So without writing anything, who knows what I'm going to write in place of this? Hands up. Okay, everybody. What gets written in place of this one? Tristan?
-2.
How many knew that was -2? Oh, not -2. 2 points for Tristan Hayden. What is it? -2x. I might have heard wrong. So -2x. How many knew it? 0.2 for Hayden. So here we go. Questions to there.
So you don't have to keep putting like f prime to that. I can just do equal.
I have to put f prime here, otherwise equal is not equal, because that would be saying that f is this, and it's not. But for this line I don't, because this doesn't change at all, like none of it, I'm okay to leave it blank. 2 for Brennan. Please, Kev.
Why wouldn't it be -4x? Are you doing the power rule?
Here?
Yeah.
So I first use the addition rule. So these two things, I find the derivative separately.
Oh wait, yeah.
Do you see it now?
Yeah.
2 points. Anybody else? Cool. Okay. If it were the written portion of the test, you would stop at this point. For the multiple choice section and for Unit 3, we need this factored. So I notice that this is a term comprised of 2 factors, plus this term, which is comprised of 3 factors. Questions about what I mean by factors? The only factor that is common to both terms is the e to the x. So pull out that e to the x. Here's my answer in factored form. Questions? Always check your factoring. Elijah.
Why did you leave it plus -2x?
Oh, it doesn't really matter. Either way. So you can write this as plus -2 or just -2. Either way. 2 points. Anybody else? Now on the back of the sheet, they did one additional step. They factored from this a -1. So it looks like this. Then they reordered the polynomial that is written here, the quadratic. That's not a required step, but that's what they did. Questions? Awesome. Next example.
So it's okay just to leave it as the e to the x outside. Can I just back it out and not have to have the mechanical one as well?
So on the written portion of the AP test, I would have stopped here. But any of these others are the same thing. So. Where you stop kind of depends on what section of the test you're working on. So, okay. Cool, next one. Please write down number 14. Yeah, don't start on the answer side. It's really easy because they look almost the same. All right, so we take the derivative of both sides again. That's not new. Okay, advice for the AP test. If they give you a quotient, unless the quotient has a constant as the numerator or a constant as the denominator, I would just use the quotient rule. You can rearrange this in such a fashion that you can use the product rule. I would not recommend that. It tends to make it harder to find a multiple choice answer. So if they give you a quotient, just use the quotient. The exception to that is if the numerator or denominator were a constant, there's easier ways or equivalent ways. Then it's kind of like quotient rule works great, other ways work great too. So You'll need me to say that again. Okay, so we use the quotient rule. The quotient rule says this. It's on your blue sheet. Right there. The derivative of two things being divided can be rewritten as the bottom multiplied by the derivative of the top minus the top multiplied by derivative of the bottom divided by the bottom squared. Okay, remember you must have good notation or you will lose points in the written section. And you'll also make a lot of mistakes. I still have people, like last period, I swear, every person who asked me for help, bad notation. Like I'm confused. I'm like, yeah, you're confused because the notation sucks. Sorry, bad word. Hey. I know. Sorry, I'm trying to clean up my language. Okay. Everybody good? Okay. No, I'm very serious. Like I had just a few people ask questions, and the minute I look at what they've written, it's easy to see why they're mixed up. They do not have a nice logical flow where equal means equal. So it's just a pile of stuff, and they're struggling to put it together. So I use the quotient rule. That gets me to there. Catch up. Please, Hayden.
Is it fine to not have parentheses or when they cancel each other?
Gotcha. The short answer is if you have two things being multiplied and there's no negative, then you probably don't need parentheses. Like if this were a negative here, I might want to put parentheses like this just to make sure I don't lose the negative. The other case where you will always need parentheses is if this factor is really two things adding. Like, let me show you one. So here parentheses are not required. But like here, I've got to have parentheses. You see the difference? Is that your question?
Yeah.
2 points. Anybody else? Just watch your test. Everybody's looking good. Okay, so again, we want to practice writing a little bit less. So please raise your hand if you know what can be written in place of this right here. Show me your head. Just do it in your head. The 17 is just a multiplying constant, so just remember, it's just going to tag along anyway, so I don't even look at the 17. Just look at the derivative of e to the x. So, Cass?
E to the x.
Just e to the x multiplied by the 17.
Yeah.
So this will become 17 e to the x. You knew it. Point and 2 for Cass. You need me to say it differently, show more steps. Okay, this one's a little bit longer. That one becomes natural log of 2, 2 to the x, dx, dx. So now we're here. Questions? Okay, cool. This is the final answer if it's the written section of the AP test. If it's the multiple choice section, you're going to have to factor. So I noticed that right here I have 3 factors. Here I have 4. I'm going to have a question on why I underlined what I underlined. So I look for the common factors. The factors that are common are 2 to the x, both places, 17, and e to the x. So next line says, I pull out those factors. This is a mistake often made. You must have a 1 here. the way to prevent that error is to always test your factoring. If I multiply this out, again, equal must be equal. So this times this is this. This times this is this one. So always check your factoring. Questions? Get that written down. Watching everybody's pencil here. Do you see anything that your brain just kind of alerts you to that it's like, whoa, I don't see why or how, or just raise your hand. So.
Should we take 2 steps to pull out the eggs there? Because when you pull it out from the bottom, the same step they pull it out as well. You know what I mean?
Gotcha. So you're saying I could get from. My recommendation is going to be to go here, and then I'll explain what I would do. Okay, you're okay. My recommendation is to go here first.
So I guess I'm missing
2 points. Okay.
where the minus 17 can be the x plus. Is when, so when you go from that step to that
So from here to here, Avery.
step. Yeah.
So factoring really means to multiply and divide simultaneously. So I take this and I divide by these. So when I take this divided by this, the result is 1. If I take this divided by this, the result is this.
Okay.
That's not your question, though.
So why are you dividing this?
Oh, that's what factoring is. So, but to maintain equality, I divide first and then I multiply.
Oh, so you're just pulling out.
Yeah, I'm just pulling out 2 to the x, 17, and e to the x.
Oh, yeah, yeah.
The
So
other way
then
to
you
look-
get 1 because it's the same.
Yes,
Yeah.
now you see it.
I
Good work.
understand.
2 points. Question, Trey?
What about the negative in the 17?
Right here.
Yeah.
So the way to think of it is when you factor something out, you're literally taking this piece and dividing by this. Can you see clearly that the result is 1? You take this right here,
Yeah.
divided by this, the result is 1.
Okay.
Do you see it?
Yeah.
Okay, I just wrote down the minus. So 2 points for Trey. Look at me, look at me. One reason why people make mistakes is because, again, they don't maintain equality and they don't read what they wrote. All you do is have to make sure this is the same as this. So here's how I make sure. If I pull, like I just test it, this times 1 is this. Then I just wrote down minus because they both say minus. This multiplied by this is that. Still don't know if I'm helping though. Trey, I don't know if I help. Not really. Something
Yeah.
that's,
I understand what the negative is now. So.
you're okay?
Yeah.
2 points. Okay, pretty good to hear. Okay, everybody look at the 1. I want to see your eyes looking at the 1. That's a really common mistake, is to forget the 1. So just test your factoring and you won't forget it. Okay, look at this word, please. Okay, please don't ever start doing this nonsense again. Like, you don't come up here and just cross things out. There's no mathematical operation known as canceling. There is none. Okay? It doesn't exist. What happens is you factor first. This is Danny's question. You factor first. Once factored, the fraction, you have seen me do this many times. The fraction can be written as separate fractions. That multiply. Now it's easy to see that this is equal to 1. You do not have to write this step. This is what I was saying to Danny. But you should be thinking it. That to create a 1, you'd have to have this fraction times this one. Since this is 1, we can write our final result as this. Question. Do not try to divide up here. It does not work. There's no canceling. Okay, only this. Please.
So we're finding the second derivative doing this.
Oh, good question. 2 points. We're still just finding the first. Look at our notation.
Oh, yeah.
You're good?
Yeah.
No worries. It kind of felt like that, but no, it's still just the firsts. Please.
So like on all the bottoms that this has been an issue, it ends up like being able to do that thing where it equals 1, like 2x over 2x. But I'm just wondering what exponents go into. Like I wrote it down because like I had a thing that it said e to the power of 3x squared, and then all of that was over 2. And like, does the 2 go to the e, to the 3, and to the 2, or like, do you know what I mean?
I have to write it down, 1 second. So tell me exactly what to write.
So e to the power of 3x, and then that x is cubed, or is squared.
Like that?
Yeah, and then all of that was squared.
Like all of this?
Yes.
Like,
See,
can I put
yeah.
a 4th there? Is that okay?
Yeah, but when we did the problem, it ended up being able to like, you know, get rid of 1, kind of like we just did. You know, see how it says 2x squared? And we were able to, our final answer is just 2x because we had 1 on the top. Yeah, so it ended up working out where I didn't have to, but like, I just was wondering where the exponent would go.
Gotcha. So you're wondering how to evaluate this if perhaps you have to?
Yeah.
Is that what you're asking? It's awesome. All eyes, come on, 2 for Brennan. Look. My advice, there's lots of different ways people will teach this. I'm going to show you what I feel like is going to stick in your head best, like, and will prevent the most mistakes. So I don't remember all the little rules and tricks because honestly I don't hardly ever need them. If I need it, I'll look it up. For the AP test, I don't need them. So instead I'm going to do what I always do, which is what does it mean to raise something to the 4th power? Somebody hand, please. What does it mean to raise something to the, I'll pay everybody. What does it mean to raise something to the 4th power? What does it mean? I'm constantly trying to get you guys to go with meaning, not tricks. Rules are good, but meaning is always better. Weston?
Times it by itself 4 times.
How many knew it? 2 points. So I just do this. This one's kind of nasty though, Brennan.
Yeah. Like if you were to kind of simplify it, would the 4 go in front of the e, would it go to the 3, and would it go to the 2?
I'm not sure yet, to be honest. I do know that in this situation, here's what I would do next. Everybody look up. Okay, I'm being honest with you. I'm doing a good job of playing the role of student because I don't remember the official rule because I haven't done this in a long time. So if I'm taking a test and I encounter something like this, like I can see from the answers I can't leave it. If it's written, you just leave it.
Yeah.
Multiple choice, I'm like, hey, none of them match. What I do next, this is a golden piece of advice, I promise. I did this for years in college and it always helped. I just think of something simple that's similar. So I think, okay, wait a minute. If I had x cubed multiplied by x cubed, that would be x to the 6th. So that's enough to remind me that this really could be written as this if you want. You can do that. This reminds me that when you have x cubed times x cubed, that's x to the a multiplied by x to the b is the same thing as x to the a plus b. Like I just use a simple example to remind myself of the rule. So you can do it that way, which means you'd have e to the 12x squared. That's one way of being equivalent. I don't ever think of like, okay, this goes here and this goes here. That's not going to help me. I'll mess it up. But I know that's true. I don't know if I'm really answering your question, though.
No, yeah, it makes sense.
You can say, no, I'm not. It's okay. It won't bother me. But is that what you're asking?
Just like how you would like evaluate that.
That's what I would do.
Okay. So you wouldn't just stick 4e 12x to the 8 or whatever.
I wouldn't because it's wrong.
Yeah.
Yeah. So.
Yeah, because like it doesn't go to all those.
Mm-hmm.
Okay.
Question? Cool. Trying to, I still can't. There's this rule, Brennan, that says x to the 3rd squared. That's x to the 3rd cubed would be x to the 9th. So you could have taken, so it doesn't help though because you're trying to work on all of this at once. It is a very confusing, like your question is really good because I agree, like knowing what to do with this is, I wouldn't know what to do either. And so written test, I would for sure leave it. Multiple choice, I'd say I can do this. Is that one of the multiple choice answers? I don't know. Could they have done something else after here? I just have to see what they did like with that. So, anybody else? Good questions. In my opinion, Brendan, you will always do well on tests because you are really good at kind of looking to the future and saying, wait a minute, what if I encounter this situation that's a little different than the problem itself? Keep doing that. It's really helpful. Cool. Next one. Okay, I'd like you to do number 5, please. Go. I'll just walk. If you have a question, stop. I'll just stop me. Do number 9. Look up for just a second. Extra credit for the whole room. I deliberately made 3 mistakes. If you can find all 3, I'll pay you 3 points. You can talk to each other. So I made 3 mistakes in getting from this line to this line. This does not make sense. So if you can find all 3 errors, I'm just doing all kinds of stuff that students do all the time. So what are my 3 errors? Okay, quiet. Let's go with Noah. Go ahead. Just tell me one, Noah.
X minus 4 on the second term has to be parentheses.
Show me your hands, please, if you saw that mistake. Show me. Point 2 for Noah. Another one, hands. Let's go, Jane.
On the second part, the d of x plus 4 should be over dx.
How many saw that one? 2. Oh, sorry, point and then 2 for Jane. Last mistake. So Lindsay.
It should all be over x plus 4 in parentheses squared.
How many saw that one? Point 2 for Lindsay. Question? Keep working. So right here, you'd have to use the addition rule first. Good. So you'd have all of this. I'll just kind of keep track of that. This would become dx dx minus d4 dx. Agreed? So what's dx dx? Good. And then d4 dx would be?
Oh.
Don't worry. So you'd have 1 subtract 0. So this is actually all 1. And then 1 times this is this. A good question. 2 points for Sarah.
Okay.
Does that make sense?
So it subtracts the 0.
Say it louder.
Okay, because on that one I like split it up with like the addition rule, but I like kept thinking that they just times together. But it's okay.
They do multiply together, but the mistake is let me show you. Here's the mistake you're making. Let's pull this down. So if I write in the step you're describing, it would look like this. It's got to be all of this. Okay, look, please, come on, look. Everybody look at the board. Everybody. Lights, look up for a minute. Okay, the key is maintaining equality. It's like it's got to be the same. So on this line, you've got this term, this factor multiplied by this factor. Next line has got to match. So this factor gets multiplied by this factor. Inside here, we did change due to the addition rule. This is 1, this is 0, but 1 subtract 0 is 1. So really 1 times this is just this.
So if the x wasn't there, then that whole side would be 0.
If this were just d of 4 over dx, this would be 0.
Because it would times.
Correct. 2 points. Questions? Folks, we'll get rid of this. Questions to hear? Why is it illegal to do this? Show me your hand. Who knows why? Why is that illegal? Let's go, Mikkel.
Because you're not showing that, it just equals down to 1. Just automatically.
Yeah, you're just drawing lines through things. Like, we don't have any indication that this truly is equal to 1. We're just drawing lines. We're just, I can't say the word, it makes me upset. So, point if you knew that. Hadley, question?
Well, you can't, that's not factor 2 on top.
This is
So
what Hadley
it's
said.
not being multiplied.
listen to what Hadley just said. 2 points for Hadley. We need the top factored, we need the bottom factored. Once both are factored, then it's easy to write them as separate fractions and do what Mikkel said. See easily that you have perhaps a 1 times something else. So don't ever do that nasty thing. You do distribute the -1. If this were a written test, I'd stop here. In the multiple choice section, they're going to make me go further. So distributing, oh, I got one for the whole room. Why do I not need parentheses here? The why is the most important part of this class. Why do I not need parentheses there? Hands. Avery?
Because they're separate terms. Like you're not working with them together. You're working with X and plus 1.
Good answer. 2 points for that. As a kind of follow-up question, this is separate from this. They are two separate terms. Why did I not need parentheses here, but I do need parentheses here? Like, what's the difference? Like, I wrote in the 1. Most of the time, you won't see the 1 written there. But why do I need this set of parentheses, but no set here? Drew?
Because there's the subtraction thing there, so you need to know that the -1 is being distributed through the whole.
That is well said. Negative this means it's really -1 times. So I've got to have parentheses to indicate that there's distribution that will occur. Over here, there's nothing operating on this now. The parentheses were originally required here because I had to say all of this times all of this. This became 1. Now the parentheses aren't needed. Please.
Does it hurt to put them in?
Does not hurt a thing.
'Cause it makes it easier for like me to organize it.
If you can see it better and it just kind of feels better, just put them in. It's
And
totally
If I
fine.
do that, then like I won't miss on accident
No.
any. So is it better just to put it on everything?
I do think you can get carried away to the point that it gets more confusing.
Yes.
But you don't need them. But now I'm going to distribute. As long as you do this, as long as at this point you realize that these parentheses serve no purpose, so this x does combine with this to make 0. The 2 4's combine to make 8. Yeah, there's no problem with that. I have seen people put so many parentheses kind of out of just nervous habit, but I think it makes it actually harder to see what's happening. But there's nothing wrong with it. I think I told you earlier, don't ever expand unless there's a reason. So don't expand this, and please, please, please don't go, oh, the 2 goes here and the 2 goes here. That's illegal. Police show up. Did I tell you that story? Oh, I did not. Yeah, good time for the story. Put your pencil down for a moment. It fits perfect. Like I'm not kidding. Don't go like, oh, this is x squared plus 16. That is illegal. Lindsay.
Just a quick question.
Yeah, please.
On the written section of the test, does it matter how much you simplify? Okay.
Well, gotta be careful. You have to finish everything that involves calculus.
Right.
And anywhere that you have something like f of 2, if there's a way to find that f of 2 is 12, you have to do that step. But other than that, there are no rules. Yeah, you just quit. So here's a true story. And then we'll do one more here. Let's do one more, then I'll tell you the story. Oh, please, question.
I still don't understand how you can simplify the numerator to be just 8 because I thought that they are separate terms.
Gotcha. A key thing to getting better and better at manipulating these increasingly complex expressions is your ability to view them in different ways. So for example, I could look at this numerator and say this is one large factor. And that's totally valid. This is one big factor. Or I can say this is really 2 terms. I can't say it's 2 factors. That doesn't make any sense. But this set of parentheses, notice, there's no value written here. There's no value written here. Nothing is an exponent. So that means nothing is operating on what is inside. So those parentheses are not really needed for anything. So I can remove them because there's no operation being performed on the quantity inside. If that makes sense.
Yes.
So now, really, I have 1, 2, 3, 4 terms. And I'm free to combine those 4 terms any way possible. So the order doesn't matter, it's just addition. So the way I see this, let's get all eyes on the board. I don't like subtraction. I think you should avoid it whenever possible. So what I see is, I see x, I see positive 4, I see negative x, and I see positive 4, and they're simply being added. Like this is exactly the same as x plus positive 4 plus negative x. You did this years ago. Plus positive 4, like they made you write in all the signs, and then they just stopped doing it. But that's how I see it. So these two x's can add to make 0, these two can add to make 8. Questions? Maya, did that make sense?
Yeah.
2 points. I think you're okay on that one. They're getting too easy now. Oh, that's a good one. Do 19. Go. And we'll finish on a story. So. Please.
I think what's getting me stuck on 8 and 10 is the same thing. I have no idea what to do once I get to my video.
So on the written section, this will be fine.
Okay.
You're right to look for factoring, but the trouble is, so for this term, what are the factors which multiply and create this term? So what I said really quickly was, sorry, there's a fact. Here's a term.
Yeah.
I can think of that term as really being 2 things being multiplied, or maybe 3 things being multiplied.
So it's 5 and x and
Slow down. It's really 5x plus 2 multiplied with 3.
2. Okay.
So that's what multiplies. So the factor here is 5x plus 2 multiplied by 3. You wouldn't say 5x is a factor. Is that?
Yeah.
Okay, good. What are the factors here?
3x, 1 and 5.
3x plus 1.
3x.
Yeah, you can't, like, it's, yeah, because what's being multiplied to create this is 3x plus 1 and then 5. That's better.
Okay.
So are there factors in this term that are identical to the factors in this term? No, so you won't be able to factor anything out.
So that just, but
You're okay.
the answer is like 1 over 5.
Right. So what I notice is the bottom is the same, which is common. So good there. What I see here is a polynomial. If I distribute, I'll be able to collect the terms.
So I am able to distribute.
The distributing is legal.
Okay.
We usually look to factor first because factoring is backwards distribution. So we don't want to distribute and then factor because we'd just be going in a circle.
Yeah.
But since we can't factor distribution,
Okay.
that's all we're doing. And the same is true. But it doesn't work all the time. Much better. I like the old equal sign. Go down the page. Much better.
You know when you accidentally hit someone's foot and then they, like, if you retract.
So really quickly again, I like did this, so I can just take that off and get rid of that on it. Okay, so then so I have to. X squared. Okay, so then once I pull it out, all I have is an x on this side. So I've got x squared plus 1 on that side, and then on this side I have like right. to combine that to get. Never mind, I got it.
Good work.
Okay.
You're good.
So you can't just, I guess it's like on some things, you can just do that and make that all equal one. And on like this one and the last one we did, you can't.
The way to tell is what Hadley said.
How do you tell?
You look and say, is the numerator in factor form? So is this numerator in factor form?
No.
It's not. The way you determine factored form is you ask yourself, it's back to what I said to Maya, it kind of depends on how you look at it, but can I look at that numerator and can I see something times something? When I look at this numerator here, do I see this as being something times something?
It's not like done.
Right, like this part of it is this times this times this, but then it's minus. So I can't view the numerator as just like chunk multiplied by chunk. Factored form means you'd have chunk multiplied by chunk.
No.
Like inside the chunks you can have plus or minus, but still you have, yeah. So like on the next line, is this in factor form? Yeah, because here's a factor 2. Here's another factor e to the 2x. The third factor is this one. So you've got 3 chunks.
If this, so if this in the bottom was that, then I could do that, or if there was one of these at the bottom, then I could. But because it's yes.
Correct. Okay. And so the real test is once you get to here, it's what I do on the board all the time. Can I take this and write it as fraction times fraction times fraction? Then you know that because of that. So some people just say, so you're doing great, but some people's mistake some people make is they'll say, oh, if there's subtraction, I can't do it. No, like look here, there's subtraction there.
Yeah.
It has nothing to do with that being minus that being plus. It's that as you view the numerator, it's not backwards. Okay. Good work.
Okay, so I guess if there's a 2 here, right, because we have to
It's part of the cube.
yeah, when you do the e, it's just 2x left to the derivative, so you have to and 2, right? So why doesn't it go into parentheses? And why does it stay out, you know?
So from this step to this step, they simply said, I've got this term, this term. The factors here are x squared plus 1, e to the 2x, and 2. These factors are e to the 2x, 2, and x. So the common factors are, that's what
Okay, I'm really close to it, but what I have inside it, I don't know where that x is for you.
it's right there. What should we do?
I got 2. Oh, that would be 2x. 2x. Yeah. And I would change those things.
Wait, that's like perfect.
Thanks. So, I'm going to choose this here, but the 2 on the outside, I'm just confused why we got that, because I have it on the inside, because it was just on this.
Let me write on the board.
Can you have it on your own side?
I can see your mistake, I just want to know where this is. Get a little short on time, so cheat. Do this.
So how did you
Oh, there you go.
I think where you made your mistake is here. Are you okay here?
Yeah.
Good. So this I'm just checking, I'm not sure where it happened. So this has to have a dx on it. So you've got the derivative of e to the 2x. So this piece here is the same. This becomes the derivative of e to the something is e to the something, derivative of the something.
Oh, I think I got that too.
Is it okay there?
Where does that 2 come from?
So this rule, derivative of e to the something is equal to e to that same something, derivative of that something. So this is 2x. You have a 2x here and here.
Yeah.
see it?
Yeah, and the two, and then.
So you get to there? Is that your mistake?
Yeah.
Please.
So I like this. What's that called? Does that make sense?
It was already there though, because they're thinking of the same. If you were to multiply these together, you have to go this times this. So if you're doing your job, it's the same. You're okay. No, you're not overthinking it. You're just thinking thoroughly. That's not a bad thing. Anybody there? Okay, the bell's going to ring. Any questions here? The homework is the pink. Isaac, question. Good work. Have a good break.